Hello, everybody. Today we'll be looking at day 3 of Mull It Over for Advent of Code 2024. So for this first problem, they wanted us to look at this string. And they want us to parse it so that whenever you see mul parentheses 2, 4, we extract it out and we multiply 2 times 4. And every time, and we keep doing that, multiply 5 times 5, 11 times 8, and 8 times 5. And then we find the sum of each of those products, and we get 161 in this case. So this was just maybe a brush up for regular expressions. So let's go over how I did it. So the test string is here. Let's comment out. This was the input that they gave me. So for now, we'll just call this S. So the key to this problem lies entirely in this pattern and importing the regular expression library from Python. So let me just go over this pattern here. So what we're concerned with is something like we want to find this mul and this parenthesis, and then there's going to be some numbers here and a comma and then some numbers here. The issue is we don't know how many numbers there are going to be. So what I've done here is I've used the digit character class, and this plus means one or more. Okay, and then same thing over here. Separate. So here's a comma, obviously that's here, and I have this digit class and one or more. I don't know how many digits there are going to be. Secondly, so I have this mul here, which is mandated. Now then we get a couple more advanced techniques. I added what's called a capture group. That's why these parentheses are here. It means capture whatever is inside of it. So that's great because later on I want to multiply them. So I capture this first number of digits, and I also capture the second set of digits. I don't know, there could be one or many. And then now this parenthesis and this parenthesis, if you notice here, they're here and here. And I had to escape them. That's something that we needed to do for regular expressions. I didn't want to confuse the regular expression engine to think I was performing a capturing. I am performing a capturing here. That's why I am performing a capture here. That's why I did not escape it. But in this case, I actually want to literally match an open parenthesis. That's why I had to escape it. And same thing here. To be clear, parentheses means something special for the regular expression engine. That's why I didn't need to escape them here, but I wanted to literally match an open and closed parenthesis. That's why I had to escape them. So I hope that makes sense. If it doesn't, let me know in the comments and I'll try to elaborate again. And that's it. So we'll just run this pattern against this string, and we need to use the find all. So because we don't want to find just one of them, we want to find all of them. So I use this find all method. So I pass in a pattern. Also, sorry, it's suggested that we use this R prefix here. Now, to be clear, initially most people think that this R stands for regular expression, but it really stands for raw string literal. So I just want to make that distinction here. And that allows us to not have to escape our escape character, or not have to escape the backslash. If we had not used the R character, this would have become something much more complicated. Something like Mull the escape character, um, and then this here the escape character. So it's just becoming much more difficult to read, and so that's why I decided to use the raw string literal prefix. And okay, so we don't really, these are just for comments, and we can just run it. We'll open this up here, and maybe Python prob 3.161. Let's go back. I think, yes, that was what we're looking for here. 161. Great. Problem 2, part 2 of problem of day 3. Sorry. Now this was the data they gave us. It's much lengthier. So what they want us to do is, again, we're given the same type of mull that we're searching for. We're searching for this mull function, or mull instruction. Sorry, multiply instruction. However, we're given these two new instructions. So whenever you see do, it enables future multiply instructions. If you see don't, it disables future mull instructions. So let's look at this example they give us. So mull doesn't have anything in front of it, so so that means we're good to go. I'm not sure where it says that, but I think it said it somewhere. Yeah, here it is. At the beginning of the program, mull instructions are enabled. Okay, cool. So in this case, we would have 8 added to our return value. I forgot what it's called. However, moving on, we can't use this mull because it doesn't have parentheses. Then moving on, we see this don't here, which nullifies this mull 5.5 and nullifies this mull multiply 3.2s. Well, this was never because of this bracket here, but it does nullify this one over here. So it nullifies these two. However, moving on, now we see a do instruction, and this enables this multiply, so that's why it's here. So we're left with the result of 48. Okay, so let me show you my thought process. So first I read the entire string, and then I did something. I said, okay, so let me just give you an example. Suppose we have some stuff. Call it here. This is some stuff, and then here's a don't. Here's a don't, and then here's some stuff. A don't. Don't. Okay, so we have that. Suppose we have that. So what I did was I said, okay, I'm going to read the string, and then I'm going to split this string, this entire string here, whenever you see a don't. Of course, I left out just to be clear, I left out the apostrophe. I didn't want to add it, but just imagine that it's there. Just to be clear, I leave it here. So I split this string, this big string, whatever they give us, I split it on whenever I see a don't. So that happens right here. I call it parts. So pattern 1 is the don't. So I look for this don't, and I look for, again, this. This is basically this here. Remember, I escaped the open parenthesis and I escaped the close parenthesis. So this is the pattern. And this happens here. So these become parts. So now parts will look something like this. Parts will equal with this first section, I'll call it 1, 2, I don't know. Well, just to make it cleaner, just to make it more educational, we'll do that there. And this one will do this. And this one will do, what will we do? Maybe, maybe not stars, maybe periods, fine. Okay, so we'll split the original string into these parts. So then we'll have this first part here, we'll go here. Then this goes here. And this goes here. Okay, great. So then, now, notice here about this first block here. Remember they tell us that this is automatically enabled. So if you notice here, on part 0, which is this part, I ran what we had from our previous problem. That's the same pattern here, the Mull. This is the same pattern from the first part, and I try to find that pattern on this first part, on this stuff here, and I do the same thing that I did in the previous part 1. So this is the initial value of total. Okay, so now this is gone, so we don't need to worry about it. I'll leave it there. It's fine. However, now let's look at this part here. Let's just focus on this part here. Comment. So let's look at this. Let's focus on that. So we know in front of this there's a don't. We know in front of it there was a don't. So what I'm imagining is somewhere inside of there's a do and another do and whatever. Notice though, what we can do is we can split this string on the do's. So again, I'll do, we'll just in order to make it clear, I'll just call these 1s, and to make this clear, call these 2s, and call these 3s, just to make it clear. So if we split these on the do's, we can ignore this 1 part because that's behind the don'ts. But everything after, we can include. That's okay. We can include that in our total. So that's what I do here. So after this first, remember I took care of this here. That's already taken care of. I have to worry about, I call these blocks. So starting the parts at 1, I loop through all of the blocks. Now for this first, I split the block here. This block, I split it on pattern 2, and pattern 2 is the do. And then I'll be left with a block, which is each of these. So that block will be 1s, 2s, and 3s. That first block, so the first one, I can ignore it. So I do that here, I ignore it. That's why I added the numerator. I added the numerate function in order to get the index so I can ignore this. I just thought it made it a little bit easier to read. I probably could have done something like this here, maybe if I wanted to. Probably could have done that and then remove the enumerate, but it's fine. And then moving on, now the matches here. The matches here are, now we have this. Now imagine we're with this string here. So these 2s, I can just find that pattern that we're concerned with. Just look for the mulls, the multiplies, and then find them. And then if there are matches, I don't even think I need this. I don't even think I need this here. Let's try that. I don't think I need that. I think I can just do this. Okay, and that was it. That was basically the entire problem. So the key part was to split the string on don'ts, and then split it again on do's. And remember to ignore the parts directly after the don'ts, but everything after that is perfectly valid. Let me just comment this out and test it and run it for you guys. So this text here, we'll just call this, we'll call this T here, and we'll ignore this here. And then I think we can just test it out. Let's do that. Let's do this. 48, and I think that was what we got here, 48. And there you go. That was the entire problem. It was a little bit tricky. It was just a matter of knowing when to use split and when to use the appropriate regular expression. I was worried that we were going to have to use something called a look ahead operator or look behind operator, and I'm a little bit rusty with that. I haven't used them in a while, so in any case, it wasn't that bad. If you enjoyed or learned something, like or subscribe. Have a great day. Take care.